So hello everyone. In our previous lecture, we had discussed about the organic chemistry. In this chapter, we are going to discuss about the periodic table and the periodic table trends. Got it? So let's start. So basically, what do you mean by the periodic table? Before understanding this, let's have some common facts about the orientation of the periodic table. Got it? So basically, let's start with the elements. I had told you the elements are a substance which only having one atom, sorry, not one atom, only having single type of atom, got it? And today we having total 108 number of elements, 108 number of elements, okay? And every element is different in terms of properties, whether these properties are in the physical form or in the chemical form, either in the physical or in the chemical forms. All the periodic tables, or you can say, sorry, not periodic tables, or the elements are differ, okay? And today we having 108 elements. So I am talking about the time period when we were finding these elements, okay? And the main challenge in front of us was that how to study them, okay? Like, suppose in English alphabets, starting from A, then B, then C, then D, and continue till W, X, Y, Z. Okay. So now we are able to understand these alphabets or to learn these alphabets because these all alphabets are arranged in a linear way, or you can say arranged in a proper manner. Okay. But what if they are not arranged in a proper manner? Like A, thereafter, first come A, then come X, then come Y, then come Z, then come F, then come G, then come K. So can you able, sorry, then would you able to study about them? Then the answer is no. Okay. To understand or to study anything, we require to arrange the things in a proper manner. Similarly, the case is for these 108 elements. 108 elements. How to arrange them? How to study them? Okay. Should we arrange them in a physical manner? Should we arrange them in a chemical manner? And how and what is the common link so that we could arrange all these 108 elements in a proper manner? So these were the all questions which we had to tackle. Okay. And with the beginning of tackling this question, the concept began. And the concept began, which was the concept of arranging the elements in the proper sequence. Got it? So these were the challenge. And in this lecture, we are going to study about some things like the Daubinier triad, like the Newland octave rule, like periodic table, and like modern periodic table. And also we will study about the trends of these periodic tables. So all these things we are going to cover in this particular lecture. Got it? So starting with the Daubinier. Got it? So remember, I had told you about the atomic mass and the atomic number. Okay. So these concepts were the main base on which these elements are going to be classified. Starting with the first one, which is the Dober-Near traits. Dober-Near traits. So basically he said if we arrange elements in increasing atomic mass form, then we will get group of 3 elements having similar properties, and atomic mass average of first and third atom will be equal to second atom. Got it? So basically he said, suppose if we starting arranging these elements in order of increasing atomic masses, then we will have a group of 3 elements, and these 3 elements will be similar in chemical and physical properties, and you can say like A, B and C. So the atomic mass of A plus the atomic mass of C and their average will be equal to the atomic mass of B. So this was a statement given by the Dobeneer. Okay, and that's why it is known as the Dobeneer traits. Got it? Second thing which we need to understand in his Dobeneer trait is that how many traits he had made, because this concept was get failed. He was not able to arrange all the elements. He only able to arrange few elements. And what were these few elements? Then these few elements are first trait containing lithium, sodium and potassium. So it is the first trait. Got it? Second trait is calcium, strontium and barium. Got it? It's the second trait. And the third and the last trait was chlorine, bromine and iodine. Okay, so these were the all traits which could be made on the Dobenier's trait statement. Okay, so these are the Dobenier's trait. Got it? Now second one is a Newland's law of octave. Newland's law of octave. Newland's law of octave. Okay, so basically he said if elements placed in order of increasing atomic mass then every 8 element will be similar to first element. So basically you can say 1, 2, 3, 4, 5, 6, 7 and 8. if this is a situation and all these elements are arranged in order of increasing atomic mass, then every 8 element will be equal to first element in terms of physical and chemical properties. So it was stated by the Newland. Got it? But this was also get failed. This was also get failed because of two things. Because of the two things. The first thing was only applied up to calcium. First thing was only applied up to calcium. Second thing was only 56 elements were discovered. Okay. So it got failed because only applied up to calcium. It could be only applied up to the calcium. And second thing was when the Newland gave the law of octave, only 56 elements were known. So there was no guarantee that this application would be also applied on the further elements which would be discovered in the coming future. So Newland made a statement and he said that only 56 elements existed and beyond 56 no element will be found. But today we know there are total 108 elements. So Newland law of octave also get failed. Got it? Now come to the most important discovery then. Come to the most important discovery. Who was Dmitry Ivanovich Dmitry Ivanovich Mendeleev. Dmitry Ivanovich Mendeleev. Who was he? He was a Russian chemist. He was a Russian chemist and he was the father of periodic table. Father of periodic table. So basically Dmitry Ivanovich Mendeleev was the person who founded the periodic table concept. Got it? Okay. So let's understand his concept of organizing the elements. So first thing, he arranged the elements into periods and groups. Got it? So periods are basically the horizontal rows. Okay. And groups are basically the vertical rows. So you can say he organized the elements in this format. Okay, in which these columns which are horizontal are known as the periods, and these columns which are vertical, or you can say these columns which are vertical, known as the groups. Okay, so he arranged the elements into this format. Let me draw it again so that you can get it proper. into this format where the vertical line is known as the group. These are known as the group, and the horizontal line is known as the periods. Got it? And what about the total number of periods and total number of groups? So the periods were total in number of 7 and groups were total in number of 9. Okay, so they were total 9 groups and they were total 7 periods. Got it? So it was his arrangement, but his periodic table was getting failed. And what were the 5 things or limitations of his periodic table? So let's start. Number 1 is that arrangement was on increasing atomic number or increasing atomic mass represented by Am. So some elements could not be placed. Okay. The second was isotopes having similar chemical properties. Or you can say different atomic masses, basically not assign separate place. Third is elements such as copper and silver bearing no similarity or no similarities assigned together. Thereafter, fourth point, chemically similar elements assigned different places. And the fourth one is no fixed place for hydrogen. Okay, so these are the basic limitations of the periodic table given by Mendeleev, or you can say Mendeleev periodic tables. So these are the limitation of it. First is he arranged the elements on increasing atomic mass order. So due to this, some elements were not be able to assign. Second thing is that isotopes which having the different atomic masses were placed together. Got it? Third point is that elements like copper and silver which having no similarity but they are put together. Fourth point is that the chemically similar elements which having the similar properties were assigned different places. And the fifth and the last one was that the hydrogen does not get any fixed position. Okay, so these were the limitations of Mendeleev's periodic table. But what are the positive facts? What are the positive facts of Mendeleev's periodic table? So let's discuss these facts as well. So first is he left place for element in future. Okay, not like the Newland who said that only 56 elements existed and no element will be discovered in the nearby future. Mendeleev tried different approach. He left some spaces for some elements. He said these elements are not discovered yet, but they will discovered in future. And these elements were, first one was Eka, Eka, boron. Second one was Eka, aluminium. Third one was Eka, silicon. So just write down these elements. These were the elements which place were left by the Mendeleev so that when they will discovered in the future, they could be placed easily. Okay. The second point was first ever genuine effect. Genuine effort of arranging elements. Of arranging elements. So you can say he made a first ever genuine effort to arrange the elements. Okay. So these were about the Mendeleev's periodic table. Got it? After Mendeleev's, next one was Henry Moseley, who gave modern periodic table given by Henry Moseley. Okay. So he just changed one thing. Instead of using atomic mass, he used increasing atomic number. So he said, beside using the atomic mass, if we use the atomic number so that we could organize the elements properly. Okay. And here are some periodic trends about modern periodic tables which we should study. So let's begin. First is organization. He continued the same organization like the periods and like the groups. Okay. He did not change it. He did not change it. All right. Like the periods were 7 in number and the groups were 9 in number, as it is in the form of Mendeleev periodic table. Got it? So he used this format. Okay. And also he used chemical symbols to represent the elements, for like H used for hydrogen, O used for oxygen, and AO used for gold. And instead of atomic mass, he uses increasing atomic number. Got it? One more thing which he added the block system. Okay. Because he divided the elements into groups. And he also introduced block. Like first two groups 1 and 2 and the helium group 18, which are found in the first two periods. These elements have their outermost electrons in s orbitals. Okay. To simplify this, you should only write down that these elements were known as alkali and alkaline. These elements are known as alkali and alkalines, and they belong to group 1 and 2. One and 2. Got it? Second, for P block, the elements known as chalcogen, halogen, picogen, and inert gases. And these elements are belong to group 13 to 18. Inert gases basically means non-reactive. Okay, so S blocks basically alkali and alkaline elements which belong to group 1 and 2. P block basically contain chalcogen, halogen, picogen and inert gases. Now D block basically contain transition elements. Transition elements and they belong to group 3 to 12. Group 3 to 12 basically occupied by these elements. And the last one is the F block elements, which basically known as inner transition, and they are normally radioactive. They are normally radioactive, and radioactive basically those elements which emits alpha, beta and gamma rays. Just write down this. Radioactive elements are those elements which emits alpha, beta and gamma rays, and they basically found their place in the F block of the modern periodic table. Got it? Now let's have a discussion over some trends of modern periodic table. First is atomic radius. What do you mean by atomic radius? It is basically the distance between the center to the outermost shell. The difference between from the center to the outermost shell is known as the atomic radius. Got it? So whenever we go left to right, it generally decreases. Got it? But whenever we go top to bottom, it generally increases. Got it? Now the the ionization energy. So basically the ionization energy is energy required to remove electron from isolated gaseous atom. Okay, so it is a simple definition of the ionization energy. Got it? So during the periods when we go left to right, it generally increases. Got it? It generally increases. But in the group when we go top to bottom, it generally decreases. Got it? So it is about the atomic radius and the ionization energy. Second one is our electronegativity. Okay. Thereafter, we having the electronegativity. It is the tendency of element to attract electrons. Okay, because electrons are the negative elements, so that's why it is known as the electronegativity, or you can say it is the element's power to attract electrons. Okay, so from left to right in period, it generally increases. But in the group from top to bottom, it generally decreases. Got it? Now, metallic character, it's generally a tendency of element to lose electrons, or you can say it is an opposite form of electronegativity. Okay, so for this condition you can say during the period from left to right it generally decreases. Okay, but in the group from top to bottom it generally increases. Got it? Now here we have finished about the electronegativity and the metallic character. Thereafter we also finished about the atomic radius and the ionization energy. Now the group behavior. The group behavior of an element is basically the chemical properties they having. Okay, so you can say because they are organized on basis of their chemical and physical properties due to atomic number as a base in modern periodic table. So that's why elements of same group will have a same chemical properties. Got it? So that noble gases, which are total 8 in number, okay, they all are inert. So you can say they all belong to the group 18 and they all are unreactive gases. They all are unreactive gases. Got it? So it is an example of group behavior. Okay. Then the periodic law, as I have told you, is a law that states the property of elements are the periodic function of their atomic masses. Got it? Now come to the significance. It is a powerful tool because it can help us to predict the chemical and physical property of an element. Okay, helps at understanding the trends, as we know that the atomic radius increases or decreases, ionization energy increases decreases, electronegativity increases decreases, metallic character increases decreases. Okay, so today we have finished about the periodic table and we have completed the chemistry part. In the next lecture we will begin with the biology. Till then, thank you.